So an arctangent becomes a little, it's a little easier to guess how we're going to do this. So arctangent looks like this, right? Okay, this is the arctangent graph. This is the tangent graph, right? So the arctangent, again, right, on the tangent graph, again, it's the vertical line test works, horizontal does not, so I have to just actually, obviously, I'm just going to pick one period right here. Right? I'm going to pick this guy right here. We're going to deal with this guy alone, okay? So the tangent, the arctangent land, we're going to go like this. And we're going to pick just this one period. Okay, so if we do that, basically what I'm going to start with is going to look like pi over 2, negative pi over 2. Right, so this is y equal to tangent, y is equal to tangent x, where the domain and the range, domain is what? Negative pi over 2 to pi over 2. Hey, quiet! Range is going to be from where to where? Negative infinity to infinity, right? You can go all the way down here to all the way up here, right? Yeah? All right. So, arctangent, I'm going to switch the x and the y's, right? It's going to look like this. Y is going to be equal to the arctangent of x. Okay, I'm going to get, again, switch this. I'm going to flip this across. Y is equal to x, right? So I had vertical asymptotes, right? Which means that now the arctangent I expect to have, instead of vertical asymptotes, I'm going to have horizontal asymptotes, right? So I'm going to have an asymptote that's going to run across this way, right? Right? And the graph itself run like that. Make sense? Okay. So here, my domain is now this, right? Because it can go all the way over here and all the way out here. My range is going to be negative pi over 2. Actually, it's not going to be brackets, right? It's going to be like that, right? This is an asymptote, it never actually gets there, right? Which means that actually this here also should have been that way, which makes sense, right? Because it's an asymptote, right? Yeah. So let's look at page 381. There's a blue box there. Read that. Before I erase that, let's go ahead and do example number 4. Example number 4 says, describe the end behavior of the function this. So it's the end behavior of this. So limit as x goes to positive infinity all the way out, it's going to try to get to what? So this is the arctangent of x. As x goes to infinity, y tries to get to pi over 2, correct? Never gets there, but it tries to. Anyway, that's the limit. That's what the limit is, right? And the limit as x goes to negative infinity, which is this way, right? Let's go down here, so it's going to be negative pi over 2. Can you see that? It's pretty simple, really, right? As it goes this way, it tries to come down here and get to negative pi over 2. as it goes that way, it tries to go to pi over 2. Okay, so that's example number 4. Now let's go ahead and flip back and do example number 3. Example number 3 is really a continuation of what we've done before. So example number 3, a arc cosine of negative 1 over root 2, I believe. Right? Okay, so what is that? Negative 1 over root 2, right? Negative 1 over root 2. So it's a cosine, which means that it is the x value, right? So it's going to be 3 pi over 3, because the domain is 0 to pi, right? Arc cosine, remember arc cosine? Okay, so it's going to be 3 pi over 4. So, okay, what did you just do? Right, so it is net cosine and cosine, the value of negative 1 over root 2. Right? That cosine is x or y? X, right? And it's negative over here, right? X value of negative 1 over root 2. Now this is just the unit circle here. Let's talk about the unit circle here.
But it's root 2 over 2.
Yeah, it's root 2 over 2. It's not, is that bad?
It's the same thing.
So I multiply top by root 2 and the bottom by root 2. Come on. Are we good?
Yeah.
I don't know what's happening.
So this is, no, if I multiply top and bottom by root 2, I get the same thing that you're talking about.
I thought it can be higher than.
I don't know.
What?
It can be higher than.
So no. So the angle, so it could be what? From either here, which is going to be 3 pi over 4, or here, which is 5 pi over 4, right?
Yeah.
But it has to be between 0 and pi.
Oh,
Therefore, that one does not work, right? 3 pi over 4, right?
yeah.
All right, so B, we already did, but let's do it again just to refresh our memory. B was the arctangent of root 3. The angle, which gives me this value, right? And what angle gives me a tangent value of root 3? And it was pi over 3, right? 60 degrees, right? Pi over 3.
Yes, it's 60.
What? Pi over
6. It's
pi over 3.
3.
what? I don't know.
Pi over 3, right? 60 degrees pi over 3. Okay. Okay. All right. This was B, by the way. This is B. Now C is the tricky one. C is the arc cosine of negative 1.1. Yeah, so you would think it would be negative 1.1, but again, it does not fall into the domain, right? Domain is 0 to pi, right? 0 to pi. 1.1. And the reason being is because, again, we are down here, right? So it's going to be here, 1.1. Okay. Now, if you thought that was confusing, let's go to example number 5. Example 5 can be either fairly confusing or fairly simple. So let's hope that you guys choose the second option here. Okay, So compose each of the 6 basic trig functions with arcsine x and reduce the composite function to an algebraic expression. Okay, so we have the arcsine of x. So this is a what? What is this? Is this a value or is this an angle? What is this? It's an angle, right? It's an angle that gives me this value. This is an angle, right?
Yeah.
So that doesn't look like it's 90 degrees. I can do better than that, right? If this is this angle, right? I'm giving a sine value of x, which means that in order to force that, I can say this is x and this is 1, right? Opposite over hypotenuse, right? Sine is opposite over hypotenuse. So if I'm going to do it this way, you understand that? That has to be that, right? Because this squared plus this squared is this squared, right? So I'm forcing this. So now I can say the cosine of theta, okay, cosine of theta is equal to what?
Yeah.
Over 1, right? But I'm not going to put the 1. Right? There's no need to put the 1, right? Because it's going to be over the hypotenuse, correct? And also, tangent theta is equal to what? This thing. However, theta is really what? Theta is this guy, isn't this? Is this what theta is? Because it's the angle, right?
Yeah.
So can I rewrite this as cosine arcsine of x?
Sure, why not?
Right, I can do that, right? I can set something over here, right? Tangent also. Arcsine of x. If you flip the page, page 384, that's what they're writing there. Okay, so I did the cosine and the tangent. You guys can do the other. It's just the flipping of it, right? Okay. But you see it, right? You see how you actually made this up. And you did it, right? Because I can another question that I could ask you a question of the same thing, but say instead of sine x, I can say that arc cosine of x. Then how would this differ?
It would be the x over the 1.
Yeah, so the x would be down here now, right?
Yeah.
And over here I would have that thing here, right? Now we just reorder them accordingly. Okay. Even worse, I can say, well, what if our tangent was x?
Oh,
Our tangent of x, then you would have what?
It would be, yeah.
No, it would be x1.
whoa.
You see that?
Yeah.
Because this squared plus this squared is this squared, right? So there are actually several different ways I can ask this question, correct?
All right.
Okay, so that's that. Let's quickly go over example number 6, and then we'll call it a day. Example number 6, the bottom of a 20-foot replay screen at Dodger Stadium is 40 feet, 45 feet above the playing field. As you move away from the wall, angle formed by the screen at your eye changes. There is a distance from the wall at which the angle is the greatest. What is that distance? Okay, blah, 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 25. Okay, so you have a replay screen, big screen really, right? This is going to be 20 feet, right? But it is 45 feet above, right? And your I is going to look like this. And we want to find this angle right here, right? Okay.
Yeah.
But I need to know this guy is X, right?
Mhm.
Okay. So what am I trying to find? I'm trying to find the difference in the angles, right? So the angle here is going to be what? This angle here is going to be arctangent of
Yeah.
right? This angle here is going to be arctangent of 65 over x. And the difference in the two is going to be just that. And you need to plot that. Okay, if you're just going to put it in your calculator and plot it. You can find out when there's the maximum angle, and the maximum angle occurs at about 54 feet. Pretty interesting stuff. All right, so we are done for the day.